So we got this hot summer day in Gulf Shores, Alabama, which, by the way, nice place to visit. Been there many times.
Oh yeah, cool.
Have you been there?
No, I've never been to Alabama.
Gulf Shores,
With a
Alabama.
banjo on my knee. Oh wait, is that one hot summer day in Gulf Shores, Alabama?
We got high tide.
At 6:38 a.m.
Roll tide.
At what time the water? No, at that time the water at the end of the pier was 2.7 meters deep. Low tide occurred at 12:50 p.m. At that time, the water at the end of the pier was 2.1 meters deep. Assume the depth of the water is a sinusoidal function of time with a period of half a lunar day, about 12 hours, 24 minutes. And then it asks us all these questions. I think we need to come up with a sinusoid to answer these questions.
I think it's quite possible. Now, so this is going to be really similar to one of the problems we just worked out, actually.
Yeah.
With, we're given a maximum and a minimum.
Right, because high tide occurred at 6:38 a.m.
So, and we know at 6:38 that we were at 2.7 meters. That's our tall part. And then we know that 12 hours and 24 minutes later, we were at low tide.
Which was at 2.1.
Yeah. So
12:50. And you just said something really smart, which was how far apart these are. It's a horrible looking 6:38 a.m. Let me try that again. Go ahead. How far apart is it?
So 12 hours and 24 minutes.
12
actually.
hours and 24 minutes.
So
12 hours and 24 minutes.
So we would have one full period after 24 hours and 48 minutes. So for the period part of that.
Is that really? That's not 12 hours and 24 minutes apart. That's 6 hours and 12 minutes apart.
6 hours and 12 minutes. That's what I meant to say is 6 hours and 12 minutes because that's half of a full cycle of tide.
Yes, exactly. So we've got this sinusoid where it's a little awkward there. We've got a maximum and then a minimum.
Right.
Our amplitude and stuff we're going to find because...
So to find your amplitude on this, what you're going to probably just have to do, because I'm pretty much not the genius that K-Steve is, I'm going to do 2.7 minus 2.1, and I'm going to get an answer of 0.6.
Okay.
That's how far from here to here, and then I'm going to slash it in half. Whoosh! And again, I'm not the mental giant, so when I divide this by 2, 0.3 becomes my amplitude. Okay, I'm going 0.3 up to 2.7 and 0.3 down to 2.1. So my A value, we've got it.
Yeah, A is 0.3.
Mm-hmm.
And then
The
our
period
vertical
now,
shift.
Vertical shift then is going to...
Since this is 2.1 and then it's going up 0.3.
Right.
That's 2.4.
Right.
To get to our middle
So
point.
so we're going to be plus 2.4 there. And then on the period, this is half of a full tidal cycle, and that tide takes 12 hours 24 minutes. So half of that is 6 hours.
No, the period with a period of half a lunar day.
Right.
This was
So
this
6
was
hours
half
12
of
minutes.
it,
Right.
which is 6 hours and 12 minutes. But we want the 12 hours and 24 minutes for our period.
Oh yeah, for the whole period. Yes. Sorry.
Yeah.
Yes.
So
correct.
we need to convert that 24 over 60. Don't we?
24 over 60 is, because
this
we do
decimal.
we need a decimal here. So 24 divided by 60 is 0.4.
Okay, so 12.4
hours
hours
is equal to the period, which is 2 pi over b.
So we multiply both sides by
we're going to have
b.
some let's see, so 12.4 divided by 2 times pi. And again, we're going to have a decimal on this, and that's okay. It's going to be 1.974. That's your 3 decimal places, always 3 decimal places. So that's the b part.
And then if this is a sine curve, we actually probably want to go this direction back down to the front of this sine curve, don't we? And figure out what that point is.
So we can figure out a phase shift.
Yeah, so if from here to here is 6 hours and 12 minutes, well, if we divide that in half again, that's 3 hours and 6 minutes. That should be how far right here, shouldn't it?
I mean, I would think so, because
Because
we're
if
dividing it evenly into fourths.
Into fourths, and so my drawing isn't really to scale here because we want to
Scales.
know what is 3 hours and 6 minutes before 6:38 a.m. So minus
So-
3:06. Fortunately, nothing tricky happening here with the whole hours and minutes thing. 3:32 a.m. is whenever it should
So
start.
32 divided by 60,
So we can get a
so
decimal.
we can get a decimal is 0.53.
And then that's our B? No, C.
That's our C.
C. And then we just have to plug all those in.
Right, so now we've got our sine equation. Now, this is actual real life stuff here. People have to
Like actually look at the tide and
people
stuff.
need
It
to know
really
when the
is.
tide is coming in and going out, and it strongly resembles a sine curve. So this is, although they have got fancy computers and whiz bangers, this is how it was used to be done.
And we're gonna, the start of this would have been at positive 3.53, so this is actually a negative,
Right.
right?
Right.
Our C is negative.
So now we can answer all these questions. At
Right.
what time of the day did the first low tide occur?
Well, that would be this point over here, right?
Well,
First low
actually,
tide?
right, but it actually occurred
Oh,
after midnight.
before that.
Yeah, because there was one
it going this
before
way.
that. So
Hang on, Dallas, we're recording. Here, open my door.
Oh, I was actually gonna come in here and ask Mr. Isaac what if he had you in the closet, locked you in there or something.
No, not locked in the closet. Sorry.
Okay.
I
Just making sure.
would never
I'll be
lock
back.
Mrs. Stevenson.
Never
in the
happened
closet.
before. Never. So we need to go back another 3 hours and 6 minutes from our starting time, which was 3:53. No, not 3:53. 3:32.
Mm-hmm.
So 3:32.
Minus 3.06.
3:32 a.m. minus 3:06, which is
Going to be 12:26 a.m. as the first low tide.
right. It happens right after midnight.
Yeah.
What was the approximate depth of the water at 4 a.m. and 5 p.m. that
So
day?
since we've got this equation set up, and we know then how everything's going to work. We know our values of x's. Our value of x will be 4 a.m.
Yeah. Yeah.
So we can just substitute 4 into this equation and solve it out. Now keep in mind that you want to have your math brain with you here. So if we get a number that says 15 or 2.9, neither one of those is going to work. We've got to get a value between 2.7 and 2.1. So I'll just punch in real quick. 3 sine
I have no idea where you got this problem from.
3 sine 1.974 times 4 minus 3.53 plus 2.4. 2.64 feet. Now, does
What was our calculator supposed to be in for
radium
this?
mode? Radium mode.
And is it in radium mode?
It is in radium mode.
2.641?
2.641. And does that make sense for
It
our
is
information?
between our values.
It's between our values.
That's
It's a good
helpful.
possibility.
So now go up and edit what you have, and instead of 4, let's put in 17.
17.
Yeah.
Got it.
And the reason we put in 17 is because that's military time.
Right.
We don't want to put in 5.
2.698.
Interesting.
Hmm.
It's almost like this is a periodic function.
2.698.
Oh.
2.698.
Oh, thanks. Yeah. See, that's what I wrote.
There you go.
When was the first time on this day that the water was 2.4 meters deep?
Well, here's what you can do. That's kind of a tricky question. What you can do is actually graph this,
Uh-huh.
and then we could also
Graph y equals
y equals
2.4 and find an intersection.
Yeah, hey, that's brilliant. So,
Totes brill.
totes brilly. So let me just graph that puppy on mine real quick and let's see here. Hopefully my graph will work out right. I'm having some trig graph issues at the moment.
Don't we all? Yeah, we're doing a video.
So 1.97, whoops, 1.97, 4 times x minus 0.53 plus 2.4. There's that guy.
I don't think that worked out.
Feeling
Shouldn't
like
it just
it's
be this
not gonna work.
3.53 over here?
I feel
Because
like,
that's 2.4, because that's our midpoint thing.
yeah, I think it
So
should be pretty close.
3:32 a.m.
Yeah, should be pretty close to that. For that's, I'll tell you what. I'll work this out to the side. You can watch and we'll double check these.
Okay.
All right. Good talk.
Yeah. Good
Bye,
time.
Casey.